Olá, você que nos acompanha. Estamos começando mais um episódio do A Caminho de Paraty, um programa de entrevistas com gente que fez a história da escola e workshop de informação quântica de Paraty. Eu sou Rafael Chaves, professor do Instituto Internacional de Física, e estou hoje acompanhado da professora Bárbara Amaral, da Universidade de São Paulo. Fomos alunos de várias edições da Escola de Informação Quântica de Paraty e estamos entre os organizadores da próxima edição.
Olá, pessoal. É um prazer participar desse A Caminho de Paraty, esperando ansiosamente pela próxima edição.
Today, we have the pleasure of receiving Artur Ekert, one of the few people to give 2 courses at Paraty. Artur was one of the first to confirm his participation for the first school at 2007, and the first to arrive. He also came back to Paraty 2011. Artur Ekert is a multiply talented scientist, teacher, administrator, as well as diver pilot, and even a former international level judo athlete. Thank you a lot for coming, Artur.
Well, thank you for having me. It's a great pleasure.
Artur, so Bell inequalities changed the way we understand quantum theory, but it seems fair to say that from the 60s to the 80s of last century, few people were really paying the proper attention to them, and the mainstream community even considered them as some kind of curiosity or even metaphysics. Until someone, in that case you, of course, connect the kind of non-locality that it's entailed by Bell's theorem with the still recent ideas of using quantum theory to generate cryptographic keys. Can you comment a little on this? What were the perspectives at that time? And how do you feel as someone who really changed the course of entire field?
Well, thank you, Rafael. That sounds like, I wouldn't say, that sounds grandiose that I changed the entire field. I didn't, but I think you are right, that somehow Bell inequalities for a long period of time were somewhere in a corner of the mainstream, right? So you had to be a bit of an outlier to look at them and to work on them. I don't know why that happened. It's interesting, right? So it's a relatively simple statement and very profound. Maybe because it came from all these philosophical discussions of Einstein, Podolsky, Rosen paper, and then John Bell coming along and saying, look, all those philosophical discussions actually are not as philosophical maybe as you think. They can be rephrased and put in a form that can be verified. It can be turned into verifiable or at least refutable physics, right? And but still, I'm surprised that, as you know, John Bell himself was doing this after hours because he was supposed to be working on accelerators somewhere at CERN, and after hours he was thinking about all these kind of ideas. Then you would have thought that right after that, there would be many people working on Bell inequalities, but that didn't happen either. So I don't remember exactly what was the sequence of events, but I think between the 60s, late 60s, when John Bell was working on the whole thing, and I guess early 90s or so, I don't remember exactly when was Alain's first, I think I'm just getting into a shaky field of chronological history. There were a few Americans who did experiments. There was John Clauser, of course, on the West Coast. There were a few guys on the East Coast, and then Alain Aspect, who probably was the one who persuaded most physicists that there's something there. So for some reason, at least in my career, the Alain Aspect experiment was the first one that somehow brought the attention to the field. But even if you look at Alain, he was also an outlier. And he was working on this, and it was not fashionable kind of physics. So why? I don't know. I think in physics, like everywhere else, there are trends. People follow certain trends, and it requires a certain courage to go outside and start walking against the crowd, right? Because everything is against you, your career, your job opportunities, or even you are risking your career in a sense that if you work in a conventional field, you know that you can tick off few papers. They will be mainstream papers. They will be on your CV, and with the help of the community, you'll probably get a job. When you're working on something that is not so popular, there is no group to support you in your career at the time. So you are on your own, and not so many people like this. So maybe that's the answer.
You probably know this story, but like when Aspect was looking like support to make his first experiment, he talked to John Bell and I think David Bohm. And the first question that both of them asked to him was if he had a permanent position already.
Yeah.
So yeah,
yes,
it was. Yes. So he was brave actually to do this experiment.
That's right. So I think that suddenly changed when with the development of quantum information science and quantum technology. So the reason I got interested in that was, I don't actually know. I was supposed to be working on something. Actually, the original topic of my PhD thesis in Oxford was related to the so-called squeeze states of light. So the idea was that you have light and you can encode information in quantized states of light, but how about if you want to increase signal to noise ratio by reducing noise, and you go to the level, the so-called quantum noise? And I did some work on that, but it never really fired me in a sense that for communication purposes, it's much easier just to increase the signal and forget about the noise, because there are some, of course, other applications where reducing the quantum noise might be important for sensing and for high precision interferometry. But then I was just looking for something that is more interesting. And out of curiosity, I was just browsing through a collection of papers on the foundations of physics, and I think I also came across Alain Aspect's PhD thesis in French. I have almost zero French, but it was easy to read because you read a little bit of a French between the equations, and I also had some knowledge I had interest in secure communication, and so somehow reading the original EPR paper by Einstein, Podolsky, and Rosen, together with Alain's thesis, came this revelation: what if I can actually apply this? This sort of proving that there is no element of physical reality is a little bit like proving that you cannot. There was nobody that touched the system, right? So that I related this to eavesdropping, and then it was relatively easy to connect the dots and just come up with a statement about secure communication related to Bell inequalities. But what I found interesting is that indeed there was a sort of like a phase transition in the quantum optics community. Out of the sudden, people realized that they can then do something interesting, have another sort of narrative to experiments. And my friends from what used to be called Defense Research Agency in the UK, John Rarity and Paul Tapster, started working on it, and that was a wonderful experience to join forces with them and do something together, and see more and more people coming into this field. So I had a pleasure to meet John Bell once in my life. He came shortly before he passed away. He came to Oxford to give a talk, and I told him about my idea. I was a little bit sort of like shy because, he was a big guy, and I didn't know whether this quantum key distribution makes that much sense. But I was surprised about his reactions after his talk. I just came to him and sort of asked him a few questions, and then I told him about this idea, and he was like surprised, and he said, "Look, are you telling me that this can be practical?" And I said, "Yeah, maybe it can." So that was the only reaction. I wish I had a chance to talk to him more about this, but that didn't happen.
Was he alive when your idea came out, or?
Well, I don't remember exactly the sequence. Certainly he knew about it from me because I told him about it. I had the impression he didn't know about it prior to me talking to him. I would have to look it up when exactly he came to Oxford to give this talk. But that was certainly shortly before he passed away.
Okay. So just a quick question, like on your personal opinion, like since some years I'm waiting for the Nobel Prize for like Clauser, Asper, and Zeilinger, but these still didn't happen. So do you have an opinion on that? Like, is it really worthy what they did? Like it deserves a Nobel Prize, it will happen. So what's your impression about that?
You know, just I think all of them did a wonderful, wonderful work. Is the Nobel Prize really like the pinnacle of recognition? If it is, then I think it certainly should go to people who worked on this stuff. I hope it will happen. I think they deserve it. But you know, as always, is that it's just not a subset of people. You mentioned 3 people. There are probably many more who contributed to this way or another. I certainly think that was a kind of a different experiment. So think about it this way. Many awards and recognition goes to people who did wonderful experiments, right? And in those experiments, they kind of confirm what we already knew. So there are beautiful experiments which show that the world is working as we expect it to work according to the laws of physics. Usually experimentals say, oh, this experiment worked. That means that it went according to theoretical predictions. Whereas actually the most valuable experiments in physics are those that go against theoretical predictions, right? So this is actually a wonderful experiment. Not the one that worked, but the one that didn't work for a good reason. And didn't work not because you screwed up something in the setup and so on and so forth, but you did everything right and the answer was different. So most experimentalists kind of know what to expect, at least what they should get for this experiment to work. Whereas I think when people like Clauser or Alan Asper were setting up their experiments, it was absolutely not clear whether those Bell inequalities will be violated or not. So I can easily imagine Alan, you know, with his curious face and a big mustache, looking at some of those experiments and thinking, okay, is this way or that way? Will it be violated or not? So that is a real science to me. That's kind of a real stuff. Because as you probably know, it was not a clear-cut thing. The experiments prior to Asper, some showed violation of Bell inequalities, but there was also a set of experiments which showed that there was no violation of Bell inequalities. So here comes Alan Asper, and everything is still open for grab. And I think that's the real adventure. That's a real kind of science to me. And for this alone, Nobel Prize should be given. And it's such a profound statement about the world as well. It just shows that, it shows many things, but it is something that certainly to realize that thinking in classical terms, thinking in terms of certain properties having objective existence doesn't quite work. And that's not easy to swallow if you think about it very carefully.
Now, jumping from last century to near past and the foreseeable future, you co-authored a recent paper on the implementation of your 91 protocol between 2 different ground states more than 1,000 kilometers apart using the Chinese satellite Micius. What do you think of these timescales for basic science to become practical technology? Do you see Ekert 91 surpassing RSA as the most used 2-part crypto protocol? When do you think quantum technologies will be a big reality rather than a big promise?
Oh, yeah, well, thank you, Barbara. So many questions in one question. So to start backwards, I think that quantum technologies will take off. And I'm not talking about necessarily quantum computing per se. As you know, there's lots of hype about quantum computers, and that worries me a little bit, to say, because almost every single day you read not very well-informed comments from all kind of people who came from the woods and or financial sector or some other sector and keep telling people all kind of nonsense. So I'm worried that public at large will have high expectations of quantum technology, or in particular quantum computing, and it will take years and years for us to deliver. And but in general, when we talk about quantum technology, such as for example, quantum sensing, quantum communication, quantum simulation, I think it's bound to happen sooner than later. And you asked me, what did I learn from my experience? When I was a student working on this quantum key distribution scheme, honestly, Barbara, I never thought it would ever happen in my lifetime, honestly, because it was just like wacky idea. You can just have a chat with a bunch of friends over a glass of wine in a bar, and then take off your PhD and go on and do something useful and forget about it. That didn't happen. Why it didn't happen? I think one thing I learned was never ever underappreciate experimental physicists. So those guys are really clever. We think, prior to meeting and working with some absolutely brilliant experimentalists, I had this view that those guys are like engineers. They simplify all our formula. We work with very sophisticated mathematics. We develop Hilbert spaces upon Hilbert spaces and so on and so forth. And they just boil it down to a few constants and a few equations, and then turn the knobs, switch on the lasers, do experiments and publish papers. So I changed my mind when I realized how much ingenuity goes into experimental physics and how much they can do. So that was a tremendous progress in quantum optics that made quantum crypto possible. But now you can see also progress in atomic and laser physics, of course, and condensed matter and superconductors. In all areas of physics, we can control nature with better and better precision. So I'm actually kind of optimistic, but I'm not as optimistic as many journalists are about our chances of building quantum computer tomorrow, right?
Artur, so taking to this quantum technologies point of view, you created the Center for Quantum Technologies, the CQT, at Singapore. Back when this topic was much less in evidence than it is today. You are also recognized for the environments you created in Cambridge and in Oxford. And the quantum sessions in Bernasca are also a very special way of bringing scientists together. And by the way, this was my first international conference back in 2007, and the one that I've never missed since then. I have a funny story that I just remembered now. I often would go to Petronia, the only bar in the city, right? And would come back like to the hotel quite late in the night, like in the morning actually. And often I would see you jogging in the morning. So you were waking up, I was going to bed. Just remember that now.
So that only shows, Raphael, that science never sleeps in Bernasca, right?
Exactly.
You have all those Brazilians who party till the wee hours of the morning, and you have all those guys who came from Far East, and they just wake up because of the jet lag, and those two communities surprisingly overlap in Bernasca.
Yes, it's very nice. The question, what gives you more pleasure, or both, of course, like to make a groundbreaking scientific contribution, or to create this nice environment where scientists can meet and science can flourish?
Honestly, to be absolutely honest with you, and I know it goes public, but let me say this anyway. So I'm not a great administrator and organizer. Honestly, I'm not. I'm actually quite a lousy one. I was just lucky because I always ended up with a group of wonderful people to work with. So, for example, you were talking about CQT in Singapore. So that happened because I ended up with a very nice community of researchers, very ambitious, very friendly, very enthusiastic young researchers in Singapore who wanted something to happen there. And the reason CQT was such a success, it was not so much because me being a director of the center, but more because of the wonderful admin support. I honestly wouldn't do much there. One thing that I like talking to people, and I like doing things together. So doing science together is a great way of doing science. So you asked what gives me more fun, to work out science myself or to run place that gives opportunities for others to do science? I think both. I like doing science myself. That's like fun for me. Running an organization has two aspects to it. One is very nice. It's joint and collective effort to do something together, to do science together in discussions, you bounce ideas, you get some inspiration from others people's point of view, and so on and so forth. So to create a fun community where everyone is equal and people talk to each other, there's no division between professors, students, and science makes it all egalitarian. So that's one aspect. The other aspect is as an admin part is always a bit of a issue for me, and I'm not necessarily one of those who. I saw many people who became responsible for things in their career and started complaining that they don't do good science because they have to do lots of admin. But it's always your choice, right? And I had to do admin, but I would never complain about it for two reasons. One is because actually at the end of the day, me not being such a great organized administrator, I was not doing this admin. Someone else was doing this admin, and I was just lucky enough to pick up the right kind of people to do it. Maybe you say it requires a certain skill or certain gut feeling to pick up the right kind of people to form a team. But once you form a team and you trust this team and there is a good atmosphere in the team and you support each other, then I think it's easy. So in this sense, for example, CQT in Singapore was an easy operation because the admin team was absolutely fantastic, the best I've ever worked with. Now the Bernasca is another story. It also shows maybe a little bit different attitude to doing science. So Ignacio Cirac and myself were asked to do it. And it was always my rebellious nature was always sort of the idea of, can we actually run a conference without any plan whatsoever, like without any schedule, have it self-organizing as a structure? And then Bernasca was a good place to give it a try. So I think at the very, very beginning, maybe there was a bit of a structure to it because there was a legacy, there was an expectation that we schedule a few talks and so on and so forth. But over time, both Ignacio and I thought, what the heck, let's see how it works without any plan. And kind of works, right? It's the only conference I know that doesn't have any talks scheduled. And nonetheless, lots of good stuff and lots of good work is done in Bernasca. So come on, it shows again that, I'm not speaking for Ignacio. He's much better organized than me, but I'm not a good administrator. And Oxford and Cambridge, the centers that officially I set up, or I'm credited with setting up those centers. Well, again, in Oxford, it happened that nobody was working in this field. It was in early days. It was like a family business. So you have a couple of people working with you, so you form a group. And you like talking to those people and people like talking to you. Other people see that there's a nice atmosphere, so they join in. So over time you grow and you have to do something about those people. So you form a center, that kind of happened this way. But, it was a long answer to your question. which do I like more, doing science myself or letting others do science? I like both. And I think I really value a lot people who create conditions for others to do science, who help others to do good science. So this way you contribute to science, but like in second order of perturbation theory, right? So you may not directly do certain things, but you know that you helped others to achieve something, and that gives you also lots of satisfaction. At least it gives me lots of satisfaction. I don't have this inflated ego that everything has to be me, and I'm happy when people just do things, and if I'm somewhere behind, I'm happy myself, and so be it.
Artur, just for the record, important part of my PhD thesis was done in Bernasca, so a lot of good stuff happens there, and I have a lot of good memories about it.
Yes, because it's yes, I do remember talking to you, of course, both of you in Bernasca, but you're right. So it's you have time to think, you have time to talk. Well, I didn't know that you wrote such a substantial thesis in Bernasca, but that's great.
Yeah, was a lot of fun. And talking about memories, now I want to ask you a little bit about Paraty. What do you think this series of events brings that cannot be found in other events? And if you can share with us some special memories from your participation in Paraty, and also about your relation with Brazilians, your Brazilian friends, and how this led to you coming to Paraty for the first time.
Well, you know that the Brazil is in quantum information science, and to me is special because we have those two Marcelos, right? So it started, I mean, as far as I'm concerned, I'm sure there may be other nestors or people who shaped the community and so on and so forth. But for me, it started with the two Marcelos. And it's a wonderful, wonderful duo. You know, you never see people like this. Good friends, good colleagues, with whom you can do everything. You can play football, you can drink wine, you can talk physics. God knows what else you can do. You can do probably everything with those two guys. So I really enjoyed having them as friends and having them as colleagues. And you know how it is, when you like each other, they can, you know, slowly I was dragged to come to Brazil and met more Brazilians. And I was impressed by this dedication actually to form a community of people. If you think about it, the two Marcelos, and if you have this sort of like a tree of people who came from that environment, it's probably quite a substantial community now. And they're probably all over the place and do interesting stuff. So Paraty, I don't remember how I learned about it, but of course, you know, when Marcelo says come, I say yes, right? So I come, and I remember my my trip to Paraty. I was driving. You know that in the community we quite often, in a very warm way, distinguish between vertical and horizontal Marcelo, so it was. I remember I was driven by Marcelo, the horizontal Marcelo, from Rio to Paraty. And it was actually quite a fun to drive together and talk, and all kind of funny things happen on the way. But at some point we got hungry and we wanted to stop in one of those places by the road. And so we walk into this place and it's full of lorry drivers, and there's a big screen and everyone is watching telenovela of some sort. And then Marcelo looks at me and says, look, man, I don't think we'll get any food here for another hour because it's the last episode of something. And then indeed, you know, they were crying. All those truck drivers were in tears. And I thought, gosh, am I dreaming? And then Marcelo says, oh, well, man, welcome to Brazil. And so on and so forth. So I came to Paraty, and first of all, I knew something about the place because I looked it up, I read about it. I knew it has history, but I didn't expect to be so charming, so wonderful, so magical in some sense. And then I remember going with the two Marcellos to some interesting places around, a hidden place to eat some food and this and that. I just love the place. So in a way, I see lots of similarities between Bernasca and Paraty. Paraty, of course, is completely architecturally and so on is different, and by the sea rather than in the mountains. But you, in terms of the community, it has a kind of similar spirit, and I like this informal atmosphere, the architecture, I kind of like this. Maybe it's not politically correct these days, but I will say this anyway. I like this colonial architecture. There's something to it, and it's a nice place to get together and talk. So I enjoyed it. I thought it was a brilliant thing to organize a conference in such a place.
I also think it was a brilliant idea to organize it there. The first time when we first met, I was only an undergrad student, and it was like super nervous to meet these important professors, and it was very nice to see that the atmosphere was very friendly, and I felt at home. It was very, very nice. So thank you, Artur. Is there anything else you would like to share with us?
Well, I would like to say that, thank you actually to give me the privilege in a way to come to Paraty. I visited twice and it was great. I think I enjoyed it. It also had, it's not like, going to a conference or a school which is sort of standard conventional, what to expect, that this is going to happen and something else will happen and so on and so forth. It's different from sleeping on a hammock outside, to talking about things, having some kind of interesting disputes, talking to and discussions and talking to students who are so eager to discuss things was great. So I hope that Paraty will continue. It's a great place to meet. And I think this place has a certain power of attraction. It really attracts people to it. It's not only in my opinion. I talk to many of my colleagues and they always say the same, Paraty is special. You wouldn't necessarily go to other standard places. I think that was a great idea. I think it will continue. I think also that it is wonderful to see Brazil being actually quite strong in this field of quantum information science. And I think the two Marcellos should be credited with creating this community, which I always think is a great thing that they did. So I would like to wish you all the best with Paraty, and I hope to revisit the place again.
We promise you that we will make our best to keep Paraty alive. Thank you very much.
Thank you.
With that, we end another edition of Road2Paraty. Many thanks to Professor Artur Ekert for his time, and also to you that stayed with us. Thank you very much. O caminho de Paraty começa aqui. A pandemia não nos permitiu organizar o já tradicional evento em Paraty em 2021, mas já começamos a organizar Paraty 2023 e aqui no canal você vai encontrar cada vez mais material para deixar todo mundo com vontade de celebrar junto à próxima edição. A edição e o apoio técnico para a realização desse programa ficaram por conta de Wanderson Davi Pacheco. A gente se encontra a caminho de Paraty. Até a próxima.